Welcome to solverfy.
In this problem, we have a mixture of two gases, which are argon and neon. We know how much the total volume is, and we know the pressure of the total system. We also know the mass of the neon, the temperature, and of course we know R because that's just a constant. So there are two ways we can approach this problem. First, we can try and find pressures because in any system, the total pressure is the sum of the partial pressures. But what we can also do is in the system, we can try and calculate the number of moles, the total number of moles is going to equal 1 plus 2, or in this case, neon and argon. We can actually say this because the partial pressures are going to be directly proportional to the number of moles. So if we rearrange this equation, we can find the moles of argon by simply taking the total number of moles and taking away the moles of neon. And if we look at the ideal gas law, PV equals nRT, and what we have, we can actually calculate the total number of moles, and we can calculate the moles of neon. So first, let's look back at that data we've been given, because we need to convert these units because not all of these are useful. So for the volume, we don't actually want to know it in milliliters. We're just going to find it in liters, which, if we just move the decimal point, it's 0.355 liters. So we have 626 millimeters of mercury. We want this in atmospheres because that's what R is in. So for every 1 atmosphere, there's actually 760 millimeters of mercury. So if we do that math, find out that the total pressure is 0.8236 atmospheres. So I know the mass of the neon, but we need to know the number of moles. That's a pretty simple calculation. We have to find the molar mass, since this is just one neon atom, because neon's a noble gas, we find out that we have 20.1797 grams per mole. So then the total number of moles for neon is kind of small, 0.007235 moles. Last thing we need to do is take the temperature. We need to convert that to Kelvin by adding 273. So then this will become 308 Kelvin. So now we actually have all the stuff we need. So your two options are, you can calculate the total number of moles by isolating this, calculating PV for RT, or we can actually just substitute this into the equation. Say that N for argon equals the total pressure times the volume over the universal gas constant times the temperature minus the number of moles of neon. If we needed to, we could substitute in this equation for a partial pressure of neon if that's what the info we had. But since we know the moles of neon, we're good. So I'm not going to write all this out because hopefully you can do that all yourselves. But if we plug in all of these different units, what we'll find is that the number of moles of argon is going to be equal to 0.00433 moles. Hopefully you found this video helpful. Be sure to come back again.